Hello friends, in this video we will look at the histogram chart, how it is made and how it is generated using Python, and manually also how you can make this particular chart, what is the significance of this chart and how it is used by a data analyst and a data scientist. So in histogram we study the distribution of data in a single variable. However, you can use multiple variables also. We can see how the variable is changing with respect to another variable, but that is using the Seaborn package. In simple Python package of matplotlib, we can only show the distribution in a single variable. So why we are going to use this is how many students have, like in this example, marks of students are given. How many students have scored 50% marks, how many have scored 80% marks. Like this we want to classify the data. So as we can see here, we have taken the same marks over here in a x variable in the form of a list 50, 65, 85, 90, 45. So this is a list in a Python and we are storing this list in X. Python is not a strongly typed language. It will automatically take care of the type of data. We don't need to declare it explicitly. So this is going to work for us. Then we have imported a already this declared package inside Python, that is matplotlib.pyplot. In this we have the various functions for drawing various types of graphs, and we are giving it a nickname of as PLT. So we are giving it a nickname of PLT so that instead of writing the whole name matplotlib.pyplot, we can simply write PLT. So as you can see here, we are using PLT.histogram function, which is known as hist, and in this we are passing x as the argument, and then we say plt.show. So this diagram is generated in which you can see we have two entries between 20 and 29. One is 20 and 25. So the marking is at 2. Similarly, other data, we have different numbers, like we have 40. So once it is occurring, then 45 is there. So like that, different markings are shown and how much data is there in each one of them, that is described. But as you can see here, these classes are not very clear. So what we can do is we can customize these classes according to ourselves using the bins. So let us see how to do that. So what we have done is, first of all, we are giving the headings. So we have plt.xlabel, which is used for giving the label for the x-axis marks. Then we have plt.ylabel, which is used to give the label of the y-axis, which is frequency. Then we can give a heading to the particular chart. So title is there, plt.title. In this we are giving distribution of students, so that is displayed over here. Then we can customize that what is the size of the figure using the plt.figure function. So before making the chart only, we have to give the figure size, otherwise it will not be considered. So plt.figure, fig size is equal to 10,6. So as you can see here, from the previous image, this particular image has become larger, and rest of the parameters are same. So just the size is shown in this particular picture. Then we are taking care of the labels and the edge colors. As you can see in the previous diagram, the edges are getting mixed up for various bars in the histogram. So how we can distinguish between two consecutive bars using the edge color? So we have given the edge color as black. So as you can see here, outline is there around the various bars, and if you want to change the color also, then color parameter can be used over here. Edge color is equal to black and say color is equal to pink, so the bars are going to change into the pink color. Then we have x label, y label, title, which are discussed previously. Then we have xticks. Xticks is going to control these labels that are there. So in this we are showing that the label should be displayed at 5, 15, 25, 35 at the center of the bin, so that we are able to read it clearly. Then the labels are from 0 to 9, then 10 to 19, 20 to 29, 30 to 39, 40 to 49. So we can see here 0 to 9 is shown here, then 10 to 19, then 20 to 29. Like this, the various bins are shown here. And rotation is vertical, that means the display is vertical. If you make this horizontal, then it will be 0 to 9 displayed in the horizontal fashion. Then we are giving plt.margin is equal to 0.2. What is it is going to control is the space here in the at the borders. How much space is going to be used as a margin, so that your data and your bars do not interfere with the border of the image. So this X6 is very important because it helps in reading the data clearly. Like here we can see that between 20 to 29, 2 entries are there. Then from 30 to 39, no entry is there. Then from 40 to 49, we have 1 entry. And like that, the distribution of the data is shown here clearly. Okay, we have, yes. So the distribution of data has become clearer. Then, if you want to compare the marks of two classes, so we can make use of the histogram. As we can see here, there are gray bars for one class and pink bars for another class. So what we are going to do is we are going to use plt.subplot, and we are declaring 1, 1. That means there is a 0 graph and there is a 1 graph. So there are two subgraphs, and figure and AX is the axis that we are going to use. So these two objects are getting created. Then we have a class A data and we have a class B data. Then AX, the object that was created here, that is used for generating the histogram. Hist class is called using AX. And then in this we are passing class A as the data. Bins is 10, that means there are 10 classes. Then edge color and color pink is passed, and for class B we have given edge color red and the color is gray. Then title is used, set title function is used with AX. Then plt.xlabel, plt.ylabel, and plt.xtext. This is same as the previous discussion that we have made, and plt.margins is also same. And then we have plt.show. So we can see here the marks of two different classes are plotted, and we can see that what is the composition. Like in this pink one, the number of students who are scoring less marks is more, whereas in the gray class we see that the students are scoring more marks, between 90 to 99. So like that we can compare the performance of the two classes. Then this is the matplot.pyplot.hist function and the various arguments through this particular function. It has bins, then range is there, that means what is the range of values, then density of values, weights, cumulative, bottom, hist type, align, orientation, r weight, log, color. So as you can see here, multiple arguments are there, and you can easily find the meaning of each one of them and what value you should assign them using Google, because a lot of help is available online. Now, how to make a histogram manually? This is very important. Suppose this is the data that we have. In this, we calculate the frequency of data in the classes and plot the data in the form of bars on the graph, with each bar representing the classes. So suppose you have a data like this with 10, 20, 30, 40, 50, then again 10, 20, 30, 40, 50, 60, 70, 20, 30, 40. So we have repeating data. So we have bins. Suppose I define 5 bins, 0 to 19, 20 to 39, 40 to 59, 60 to 79, 80 to 89, and 100 and beyond. So we can see here between 0 to 19, 2 entries are there. 20 to 39, 6 entries are there. 40 to 59, 5 entries are there. And when I plot a histogram, this one I have generated using Excel. So we can see here 0 to 19, 2 entries. So we can verify from here. 0 to 19 we have 10, and then we have 10 again. So 20 will not come here because it is 0 to 19. So 2 entries are there. Then between 20 to 39, 20 is there, 30 is there. Then again 20, 30 is there, again 20, 30. So 6 values are there. So the bar is at 6. So like that this diagram has been plotted. So first you make the classes, That means how many classes you want to define, and then what is the frequency of the data that is appearing in that particular class. So you just put the number over here and then you generate the histogram. Now, what do you understand by looking at a histogram? So when we look at this histogram which we have constructed in the previous slide, what do you understand? So what we understand is that the range of values is between 10 to 60. Between 10 to 60 more values are there as compared to 70 to 100 or 120. So more values are centered around 10 and 60. And what can you say about the mean of, okay, as the bins are rising, the entries are becoming less downward. So there is a downward trend. So as the bins are rising, we are having less entries. So there is a downward trend line. This was also generated using the Excel. Now, what can you say about the mean of this particular entries in this particular graph? So as we can see here, more entries are centered around 10 to 60. So we have an average of around 45.2. So we can easily conclude from this particular graph that this is the area of concentration of the values. So therefore the mean is going to be somewhere around 50. Then what is the meaning of mean? That more and more values are centered around this area. This is what the mean means. Then we have, what can we say about the standard deviation? That how much data is deviating from the mean. So here we have a standard deviation of 26.7. So generally we are going to find the type of distribution in a particular variable, whether it is a normal distribution, it is skewed, like this one is a little bit skewed distribution because the peak is not in the middle, it is towards the left. Then we can find out what are the outliers. Like here there is only a single value of 100 which is not there in the remaining data. So we can find out that whether this marks above 100, between 100 and 150, 120, whether it is an outlier which is different from the other data, due to which the mean is getting impacted a lot. So we can find the outliers and mistakes in the data using the histogram. So there are mainly 4 types of histograms that we can have. Symmetric, in which the peak is in the center, which is a normal distribution. Then we have positively skewed, that is which is skewed towards the right. And then we have negatively skewed towards the left. And we have bimodal, in which we have more than one peak. So in case of bimodal, we have to separate the data into separate variables. This is what it indicates, and we have to study them separately. So why we are going to use a histogram? To study the data distribution, what is the shape of your data. Then if you want to compare different data sets, as we have compared class A and class B data, so that we can perform. And if you want to communicate to a general audience that how the different data are represented in the histogram, that is more intuitive for people to understand. Okay, in the next video, I'll be discussing how to draw a histogram using a seaboard. And I hope this video is helpful to you in understanding what is the role of histograms in a data analysis or exploratory data analysis. Thank you very much.